Good afternoon and welcome to this webinar, Get in the Loop on Open Loop Geothermal. This event, brought to you by ACHR News, is sponsored by ClimateMaster. I'm your moderator, Angela Harris, E-Media Development Specialist for the ACHR News. Thanks for joining us. Today's presenter is Sean Hogan. Sean began his career in green technologies in 1981, installing solar and geothermal systems in the Pacific Northwest. He quickly recognized the unique opportunities and benefits pond loops presented and began to focus his marketing efforts to waterfront property owners in the greater Seattle area. Sean started his own HVAC company in 1984 and has installed well over 600 pond loops and countless ground and open loop systems that include large mansions, houseboats, private yachts, the U.S. Navy, and a cruise ship. Sean is a technical trainer for ClimateMaster and IGSPA, traveling across North America teaching his do-it-right or stay-home approach. He continues to size and design systems, consult on projects, and test new loop designs, equipment, and accessories. Sean also lives what he teaches, having enjoyed the comfort and savings of geothermal, providing his rural Seattle area home with heating, cooling, and hot water with solar assist for nearly 20 years.
Thanks for joining us on this open loop geothermal design and applications. Got a lot of stuff to cover, so let's go ahead and get this candle lit up and see where it takes us. Open loop groundwater systems. We're basically talking about taking well water and running it through the geothermal heat pump and then discharging it. Let's take a look at a few of those applications. In this slide, you'll see that we have a production well and then a rejection well. That's one of the many types of applications you can apply on open loop systems, but not certainly the required one, although it might be in your area. Another one would be a standing water column. This is where you're actually using a very deep and typically large water well, and you're going to cycle that water to and from. But I want to quickly warn all of you, do not attempt this without getting an engineer involved that has a great deal of experience. This is a very, very highly technical and skilled area. I would not attempt it even after having all my experience without engaging people that know how to size them and set the pump and the flow rates specifically. So I just wanted to include that this is in there. This is available. However, you really need to reach out and make sure you're dealing with some people that know how to assist in sizing and designing that kind of an application. The advantage of the water source heat pump, well, it's a renewable energy. You'll never outrun that well unless, well, you run out of water. High efficiency. That ground temperature, which obviously is influencing the temperature of your water coming out of that well, moderates the performance of that heat pump. We have no defrost cycle. We don't have outside units typically, especially with open loop. Longer operating life and quieter operation. Sometimes that's significant, depending on the location where you put it. And this little fun little slide here where it shows what happens on an occasional abused and not really well maintained air-to-air heat pump when it starts to frost up. Benefits. Well, it's the lowest first cost of any geothermal application that I'm aware of because, well, you avoid the cost of a loop. Typically, there's no large lands required. Fast installation for retrofits. I've done a number of them in one day. Some of the obstacles occasionally can be regulatory constraints. You always want to visit this first and foremost to make sure that this is something allowable in your area. It varies certainly from region to region, state to state. It requires, and I want to emphasize that, it requires good water and will bring some maintenance involved. Sometimes you have to increase the size and or quantities of the well pressure tanks. And you always need to ask this question, where are we going to discharge the water when it leaves that heat pump? Because you do have to deal with that. Don't overlook that. So the three absolute must requirements that you as a contractor, designer, engineer, architect must verify, whoever's looking at proceeding with this project, is basically kind of like three legs to that stool that have to be answered. Do you have good water quality? Do you have good water quantity? And what is going to be the discharge method or that location? If you can't successfully apply a yes, or if you can't satisfy the need to satisfy all three of these, you don't want to proceed with it because you certainly don't want to have a bad application out there. So some of the basic design rules. Water well system components will sometimes require upsizing of the expansion tank or the well pressure tank, supplying both the domestic use and the water source heat pump. We're going to cover that here in just a minute. Constant pressure systems, or CP systems. Basically, that's a variable speed pump and an inverter. These are very nice. They've been around for a number of years, showing very, very good energy savings as well as good performance and longevity. And the price is getting fairly competitive for residential water well pumping. You need much, much smaller expansion tanks. You're going to see that coming up. Word of warning. Never, ever, ever use lake or pond or any other kind of surface water directly through any kind of a geothermal heat pump. The hazard and risk to that is, well, you don't know how the water quality will be. It might be okay today, but what will it be tomorrow? And you can actually install something that can then turn out to be a nightmare for the end user. So again, never, ever, ever use surface water or lake water directly. And in most places, they don't allow you to pump lake water through anything, a heat pump, and oftentimes it's now even difficult for irrigation. Constant pressure well systems. Here's a couple of examples. There are a number of manufacturers out there. On the left is the Grundfos, is just a brand name. You can see some of those components. It's typically a very small pressure tank, similar to what you see on a water heater or a hydronic system in size. It's a little bit different bladder. You can see the small controller, submersible pump, and they have a transducer which is monitoring that pressure. So that well pump is actually down in its location in that well, and when the consumer opens up a tap or anything that causes the water pressure to drop, this control system will pick that up immediately, and it spools up that variable speed well pump immediately. And it's about the closest thing you're going to get to municipal water pressure. The typical well pump system, which we're going to get to in a moment, you'll actually have some variation in that pressure by typically 20 pounds, sometimes a little bit greater. And the other thing about the CP systems is that these pumps typically have a significantly lower amp draw, so they're going to save a fair amount of electricity. We're going to talk about that here in just a minute. Here's one that was measured here just a couple weeks ago, where they had a number of outside faucets running and some other consumption going on in the home, and this CP system only was drawing about 2.5 amps. So there is significantly lower electrical consumption when you are considering using a CP system. Again, that variable speed pump. It spools up to match that load. Got to be very careful that you don't put in or apply a geothermal heat pump on a large horsepower well pump that's going to eat up all the energy savings that you were trying to get from the geothermal heat pump. As I just mentioned, make sure that you don't have that large horsepower taking away the savings from that heat pump. So let's talk a little bit about the typical well pump and pressure tanks. You want to pay attention to the pressure settings. Typically, they're 30 to 50 or 40 to 60. The lower pressure is when that pump's going to turn on, and of course, the higher is when it's going to shut down that well pump. You want to minimize that cycling of the well pump, because with a lot of electric motors, the real large energy consumption and draw is when it goes to start. So you want to pay attention to that, and it's fairly typical that you need to add a couple of pressure tanks, 1, 2, or 3. It really depends on that application. You got to make sure you pay attention to the drawdown capacity of that particular bladder tank or pressure tank. So here I just use one particular brand called Wellmate. It doesn't really matter which one you use. What a lot of folks don't know is they'll tell you, I have an 80, or in this case, let's pick it, an 87-gallon pressure tank on my well. Well, that is actually not the amount of water capacity that that tank gives you. If you were to fill the entire tank up and it didn't have a bladder, that's what it would hold. But if you look over to the right, the highlighted area, depending upon at the top of that column what your turn on and turn off pressure is, you can see actually how many gallons you have to draw down before the pump's going to start. So that 87-gallon that a lot of homeowners will tell you they have, well, if it's a 30 to 50 PSI rating, they're only going to get about 26 gallons of drawdown before that pump turns on. Or in the 40 to 60 range, well, even less, because it's a higher pressure rating. So The drawdown capacity is something you really need to pay attention to when you're sizing up. Okay, how can I keep this well pump from turning on and off a great deal? So you want to get down to a point where it'll turn on and then run, and not keep cycling on and off. So often you want to consider adding a few pressure tanks onto the system. 2 or 3 is not unusual. Again, remember that homeowner has avoided the cost of a loop, so this is not a deal killer at all, because a ground loop is, thousands and thousands of dollars, and well, pressure tank, they're $300-400 each, plus some installation labor. So again, it's a good application. Just make sure you go in, maximize that savings for that homeowner, and apply it correctly. So one of the questions we oftentimes get in geothermal is, how much water do I need? Well, depending upon your location, if your water temperature coming out of that well is 55 degrees or greater, you need, rule of thumb, about 1.5 gallons per minute per ton. If you are less than a 55 degree annualized entering water temperature, you want to make sure you have every bit of 2 gallons per minute per ton. Now, if you look in the highlighted area to the right in the circle, it's part of our ClimateMaster performance specifications, but most manufacturers have very similar methods of displaying their performance. And you'll notice that ours is grayed out. And when you're in the heating mode and you're dealing with cooler temperatures, one of the things that's important here is that you want to make sure that you set up your flow rate so that you have a leaving water temperature. In other words, after in the heating mode, the heat pump has drawn that temperature out of that fluid. You want to stay above about 40 degrees to avoid a freeze protection thermistor or sensor nuisance fault. Because again, most manufacturers, including ClimateMaster, we place our freeze protection sensor on our refrigerant line. We're not actually measuring the water temperature. We're measuring the refrigerant temperature. And when you get a very cold water, sometimes you need to actually elevate that flow rate so the water has less time in the heat exchanger to extract that temperature, thus keeping it up a little bit. So the rule of thumb here, again, I don't like rule of thumb in geothermal, is below 55 degree entering fluid temperature from your well, you want 2 GPM per ton. That's kind of a minimum. And again, if you're starting to flirt with that 40 degree temperature leaving the heat pump in the heating mode, then you want to elevate that flow rate to make sure that you maintain that leaving water temperature a little bit above that 40 degrees, because you don't want to keep going out, nor does the homeowner want to have these little red lights turning on saying there's a problem. So make sure when you're doing a startup on a pond loop system that you are in fact paying attention to that. That's part of good startup procedures for any technician. Here's an example I highlighted. This is from our particular sizing software, GeoDesigner. This particular unit was a 3-ton. You can see at the very top the water flow at 5 gallons per minute. And one of the things that you want to be prepared for as an installer, as a contractor, as an engineer, you want to pay attention to the annual water use. And yes, that one in that example is 664,000 gallons. Yes, that is a lot of water. However, if your homeowner sees that, be prepared. One of the first things they're going to do, their initial reaction is going to be, oh my goodness, I cannot possibly waste that kind of water. So what you need to do is basically you want to identify that concern. You want to say, I agree with you, that's a lot of water, and certainly I wouldn't want to be considered someone that's wasting water. And I want to just point out quickly, we're not wasting water. We're using that well water as a vehicle. We're using it as a vehicle to bring temperature to the heat pump. So that water, as it enters the heat pump, is safe to drink. It's potable water. When it leaves the heat pump, it is still completely safe to drink. We have not altered it chemically. We haven't changed it, tainted it, contaminated. All we've done is made it a little bit cooler in the heating mode, or in the cooling mode, we've added a little bit of temperature, and then we're going to discharge it back into the ground. Over time, that water is going to travel back down through the earth, and it's going to go back into that or another aquifer. So we've essentially recycled that water using it again, as I want to reemphasize, as a vehicle for temperature, so we're not wasting the water. So you want to bring that assurance to that homeowner. They're not wasting water. They're just using it as, again, a transport vehicle for temperature. Retrofit applications. Folks, I can tell you, when I got phone calls with homeowners saying, hey, I have fabulous well water, and I want you to come up and install a geothermal heat pump. Well, that didn't cause me to jump behind the windshield of my vehicle and drive up there. It meant that I had to ask them a lot of questions. For example, do you currently filter your water? And if the response was yes, I would say, well, what would you be filtering if you have such great well water? And I always listen intently to that response, because it'll give you indications whether you have a viable candidate, because you don't want to have to do a lot of filtering to provide the water to your heat pump, because those maintenance costs, number one, over time will get neglected, or number two, it could start to take away from the savings of that heat pump and make your customer less than happy about their installation. Mr. or Mrs. Homeowner, have you ever run short of water? In other words, on a drier or a year where you don't get much rainfall, do you have an issue with the amount of water available to you? Always want to ask that question. Do you experience low water pressure in the home? Now, this is not necessarily indicative of the quality of water. It may be indicative of their delivery system, but believe you me, when you're going to install a geothermal heat pump, it's tied into their domestic water supply that affects their home. You want to make sure if they're having some concerns or they're kind of struggling with some delivery water pressures, you know that going in so you can address it. You don't want to be accused of it after the fact. And, well, that's kind of difficult to plug in some of those resolutions into your estimate after the ship has sailed. Where, Mr. and Mrs. Homeowner, can we discharge that water to? Where did you have in mind? Remember, when this unit runs, we need 2 gallons per minute per ton. And kind of give them a general idea what they're looking at. Sometimes people have a pond or a creek. You want to make sure that is allowable for the municipal regulation. Where are we going to put it? One of the questions I've learned that you need to answer, are you the only consumer on that well? Sometimes there's multiple properties being served by that same well, typically called a Class B or greater well. It's not really fair to tag the community with a little bit of an electric bill to service your heat pump. So, you want to be aware going in. It doesn't mean it's a deal killer. You just may need to get the other consumers okay to do that. So, again, questions you want to make sure you get answers to. Water quality, probably the biggest area that guys neglect. Probably the biggest culprit of problems that we see out there is the water quality, and I'm telling you, this is paramount. When performing a site visit, you always want to inspect the sinks. Again, I'm assuming this is a retrofit application. The project is already built out. When I come into a home, I'm looking around to make sure, number one, that home is a heat pump candidate. It's well insulated. It'll retain that temperature. But I'm also walking around, and I'm going to be a little bit nosy, because I want to see what kind of water quality you have, because I'm going to tell you, folks, homeowners sometimes are not always directly honest with you. I know it's a shock, but that's just what I've learned. So I'm walking around, I'm taking a look at all the sinks. I'm looking for indicators like staining, water spots, things of that nature. Toilet bowls, toilet tanks. I'm telling you, toilet tanks tell the tale. I always, by the way, have to go into their bathroom, even if I don't have to go to the bathroom, because I want to see the toilet bowl, and I'm going to lift the tank lid and look inside, because anytime you have some of these toilet cleaning tablets, typically those have some bleach in it. Bleach is an oxidizer, and anytime that there is components in suspension in that well water, and you create add an oxidizing agent into that fluid, it's going to precipitate out of solution, and it's looking for something to attach to. So typically, you'll see that in the toilet bowls. Also, air is an oxidizer, or oxygen. So if you take that toilet tank lid up, remember that volume of water is open atmosphere, and again, air is an oxidizer, and you'll have precipitation. And let's face it, how many people go in and clean their toilet tank? So typically, they may fool you in other areas, but they're not going to fool you because they didn't think about the toilet tank. So I will always go look at that. So here's an example. Oxygen is a natural oxidizer. Open atmosphere well water can create staining if you have staining components in it. This example right here, there was a half part, that's 0.5 parts per million of iron. But because they didn't treat it, they didn't filter it, and it was open atmosphere, here's what happened. It precipitated out into the toilet bowl. Now, this doesn't mean you can't use it through the heat pump. It just means you need to monitor it after that geothermal installation so that you'll know when you'll need to come in and flush out that heat exchanger and scrub it back down so you get good transfer. So this is not a deal killer, but you need to know this going in so that you can suggest what kind of maintenance levels they may need. Here's another great one. Dishwashers, especially those that have the off-white or light green kind of a rubberized coating inside, because virtually all dishwashing detergents have some kind of bleaching compound in it, and well, again, it's an oxidizer, and now you're going to add heat, which really accelerates that precipitation, and it's looking for something to attach to, and well, you can see what happens here. Now, this won't help you at all if they have a stainless steel dishwasher, but in this example, this was that same home with the toilet that had that toilet bowl staining, and you can see here that iron and manganese in this case, which is the black spotting, it was ever present in that dishwasher. So again, indicators on an existing residence if you can find out what you're dealing with going in. I own a basic water test kit. That's mine right there, and I did test to see what levels of iron, because again, it's going to affect whether what kind of heat exchanger I'm going to choose to use, as well as the recommended maintenance levels. And that's not the only test, guys. pH and iron, I always check for total dissolved solids, which is the particulate. I do a number of tests in the field, but that's just the beginning for me. Water pH is critical for that life of the heat exchanger. Acidic or high alkalinity water will cause catastrophic failure in short order. Again, it depends on just how acidic or how high levels of alkalinity you have. If you hear the phrase from anybody involved of iron bacteria, and oftentimes it's referred to as bacterial iron, well, that is not a candidate. Do not make that an open loop system, but remember, it doesn't mean they can't have geothermal. You're just going to have to make it a closed loop system. Okay? They didn't qualify for open loop, but the good news is we can still apply geothermal. We can go directional, vertical, horizontal, ground loop, whatever you think you can apply for them. And I don't walk away from an installation. I just make sure it's a good installation. Always, always have that well water tested. And here was my procedure as a contractor. When we felt, and including me, if I felt that they had a good application, we had good water quality, we had good quantity, and we had a good place to discharge it, we were in agreement that the value was there for them to proceed. I always, and I want to emphasize this, I took control of that water sample. I took a sample out of their faucet. I would take that, it never left my possession, I would take it to an independent water testing lab, and it cost me $65 to $85. And I paid for that water test to be performed. And by the way, if there is any kind of a rotten egg smell, that is hydrogen sulfide, you want to make sure that you get that water sample to that testing lab right away on that same day, not an overnight thing. Make sure you have a lid that's sealed tight, and when you bring it in and you fill out the paperwork, let them know you suspect hydrogen sulfide and you would like it tested right away, because hydrogen sulfide is a gas that will outgas and dissipate, and it will be difficult for them to test for that level, because that is a critical thing you need to be aware of if it exists at all. Always keep a copy of those independent laboratory test results. I always attach those to a copy out of the manufacturer's handbook of their acceptable water standards for their heat pump, and I put that in my job file for several reasons. First of all, you want to make sure it's an independent testing lab because they have no skin in the game. In other words, you're not influencing them. You paid for this. This is what they do. It's on their letterhead or their report, and it's dated, and all of the results are right there. So you have done your homework, and you've pretty much covered yourself. Word of precaution, never use a pool or spa test facility as an alternate. because it's a very, very limited test. And please never use a water treatment company such as, for example, Culligan. And hear me clearly, Culligan is a great company and provides a super service. You don't want to use that kind of a company because, well, they're in the business of selling water treatment systems, and I'm sure they've probably never seen water they felt was acceptable for use under any terms. So again, I'm not putting them down as a service. You want an independent testing lab to take a look at that water to make sure it provides you the information you need to compare, we're going to see in a moment here, to the manufacturer's limits. Is this a good candidate to proceed with? Again, you keep hearing me emphasize to make sure that you have verified you have good quality of water. So again, this kind of talks about, in this example, in the ClimateMaster All Products Technical Guide, you're going to see this in there where we have water. What are those water quality standards, and as it relates to temperature as well. All right, so let's spend a few moments here. This again is in the ClimateMaster, but is very similar in other manufacturers' literature. This is the water quality parameters. You're going to see some columns here. I've highlighted a couple. So the kind of an off orangish or off white is HX material, in other words, heat exchange material, because you do have some options and there's some times you want to start making some changes. You can see as you start to go through some of the acceptable limits for that water condition. You'll see to the left the description, and over to the right you're going to see what range is acceptable and or what you may want to consider doing. So there's a couple of them I want to bring to your attention here, and I highlighted them over to the right. That is hydrogen sulfide. If it's a very minor amount, we're telling you can probably use it. If it's too much, well, you're going to want to separate that out from our heat pump or any other manufacturer's heat pump with a separate external heat exchanger. We're going to cover that in a moment. You want to be very careful because frequently hydrogen sulfide will start to attack copper and bronze fittings. So you want to be very careful about the materials you use so you don't install a problem that's going to show up here in short order. The other one is chlorides. If you have any chlorides at all, you're going to see under the heat exchange material column, you're going to see what we recommend based upon a couple of things. The amount of chloride as well as what's the temperature range you're going to be operating in. And don't forget, for a lot of you, you're going to hook up the hot water generator, that small heat exchanger that provides free hot water to the water heater. Well, if you think it through, folks, we're producing, oh golly, you can produce 125, and in some cases you can get in even higher temperatures out of that hot water generator. So if that is the same water coming out of the well they're using in the home, and it has chloride, you may not have an issue possibly with the heat exchanger that we're doing our heating and cooling from, but that de-superheater or hot water generator coaxial heat exchanger could you could compromise it because the chloride and temperature made it aggressive and ate through. So you're going to see here copper, cupronickel, and stainless steel and titanium. You're going to see what those allowable limits are, parts per million, along with that rated temperature. So please be careful. If it was me and there was any amount of chloride, personally, I would put in at minimum a stainless steel braze plate heat exchanger external. We're going to show you that here in a moment. And again, depending upon the amount of chloride, if I was going to proceed with the project, it might even be a titanium, because again, this is still less than the cost of a ground loop system, so you still have a good candidate. So again, making sure that you pay attention to the independent testing lab results of the water you're dealing with, as well as making sure that you're applying the correct kind of a heat exchanger so that you don't install a problem down the road. Unhappy customers. So here's an example of a failed heat exchanger due to the poor water quality. And this one came out of Eugene, Oregon. 2 years of operation, and because of that chloride level, it ate through the Cupronickel heat exchanger. By the way, the minimum kind of a heat exchanger you should have if you're going to subject it to well water, in my opinion, is a Cupronickel heat exchanger. It has some adherent benefits. Speaking of which, Cupronickel is a more abrasion-resistant element than copper, and it adds very little cost to the heat pump. Here's another always must do, folks. Always install a solenoid valve on the outlet of the heat pump to keep that heat exchanger under water pressure and fully flooded. Again, you want to make sure that you do that, because if there's any componentry in that, any metals, your manganese, your iron, things of that nature in suspension, you want to make sure that it's not subjected to the air so it can precipitate out and attach to your heat exchanger, thus inhibiting your BTU transfer. So you always want to make sure you keep that heat exchanger fully flooded and under pressure. And again, by installing that solenoid on the outlet, you'll accomplish that. Always, always, always install pressure and temperature ports, or peach plugs, isolation valves, and flushing ports. You're going to see that coming up here. Perform a well capacity test. This is something I did very often. I asked them when everybody was going to be home. Again, retrofit application. If I was going to put in a 3-ton and it was going to run at 6 gallons a minute, I would run probably 2 garden hoses, assuming I'm now running about 10 gallons a minute, and sometimes it could be even 12 or 14, depends upon that particular water system. And I'm going to terminate those garden hoses over into the vicinity. We're talking about rejecting that water too. And I'm going to ask them when they get home Friday night, I want you to run all these outside faucets 24/7 until Sunday night. And I want everybody home. I want them to be doing laundry, washing dishes, showering, washing the car, doing the things they normally do. I'm doing several things if you think about it. I'm testing that well capacity. I'm testing, will they have sufficient water pressure in the home, or do we need to address it? And then, will that discharge area, will it have the absorption capability? Again, assuming we're discharging in the ground. And what I oftentimes did was a very little perforated pipe in the earth. So this slide, we're showing a couple of options for the motorized valves. Left one is it's a TACO valve, but it is CV rated. In other words, it has the ability to move that volume of water through. It doesn't have a lot of restriction. And folks, I want to caution you, if you look at it, oh, that's just a hydronic solenoid valve. This one is different because it has a higher CV rating. So I urge you, don't go down to your hydronic supplier and just get any solenoid valve, because it may end up being too restrictive. A lot of what we're doing now is we're putting in a Internal Modulating Valve with our communicating product, so we're varying the flow based upon a temperature difference. Those are very nice valves. We'll talk about them here in a moment. Flow regulators are oftentimes used. You've got to be a little careful. Sometimes those can be a little bit noisy. So here's an example. You can see that the pressure tank is in place. This is your typical well water systems. Some folks like a spin down kind of filter in case they, all of a sudden get some sand or something like that. That's not a bad idea as long as it's maintained. Always put in full port isolation valve so you can isolate the system. You can see here the water control valve or solenoid valve is on the water outlet. You can see those PT ports that I mentioned, as well as those boiler drains. Those boiler drains are the access so that you can have the ability to flush that heat exchanger, because remember, open loop will need some level of maintenance. Here's an example for, you can see kind of the bottom of the page here, figure 26, two-stage piping. Most of these geothermal heat pumps that are installed today are 2 speeds, and you only need 67%, or let's call it 70% of your water flow on first stage. So it may make sense for you to consider putting in 2 different solenoid valves. One that operates at 70% water flow on first stage, and when you have a Y2 or high-speed call, then the second valve opens, but only make sure you're dialing in and bringing in the remaining amount of water it needs to, so you get that total. Installation. Well, those pipes are typically going to sweat depending upon your particular location, so you want to make sure you fully insulate them, and always bear in mind, if you're in a heating dominant climate, freeze protect that pipe. Remember, it's not just a supply pipe. Now you've got a discharge pipe. So if you're going through a crawl space or some area where it can be exposed to low and freezing temperatures, you want to make sure it doesn't freeze up, because, well, then it's going to shut down because it's not going to get the water flow it needs. Pressure regulators sometimes can help with water noise. You've got to be careful that you're not introducing the rushing sound of water through a pipe that gets transmitted through the home. And again, that includes attachment of that piping to the structure, so you're not, again, transmitting and amplifying. I really encourage you, flow meters and or flow setters are not recommended. They typically will cloud up. You won't be able to see them as far as the flow meters, so it's just a temporary fix. You really don't want your homeowners having that access to that kind of information anyway. So again, just keep it simple. We showed you that drawing just a moment ago where we showed the ball valves, the flush ports, which were the boiler drains, as well as those pressure and temperature or Pete's plugs adapters. Those are an absolute must on every installation. Size the piping. Always pay attention. Now, this is the area a lot of guys get into trouble, and I just wanted to show this because a lot of contractors will say, well, gee, I can do this with 3/4 inch copper. But a lot of guys are installing PEX. I want to hasten to tell you, I love PEX. I think it's great. However, you're not going to get the same amount of flow rate through 3/4 inch PEX that you will through copper. So let's look at it. If you get to or beyond 4 feet per second of a velocity through the pipe, you're going to start to transmit noise. You're going to create noise in that house, and that's typically never acceptable for most homeowners. So you want to stay south of 4 feet per second velocity. So you can see the flow rates here on the various kinds of pipe. 3/4 inch copper, you can get 3.2 gallons per minute at 2 feet per second. You can almost double it when you double that flow rate. Again, you may be introducing noise. But let's go down. Let's take a look at 3/4 inch PEX. Well, we're at 2.3 GPM and 4.6. Again, well below what you're probably going to need, but most guys don't understand that the internal diameter is smaller on PEX pipe, but remember guys, the connector goes inside the pipe. That's where your greatest restriction is. So again, I like PEX. I think it's a great material. You need to pay attention to the diameter and what you can get through it quietly. Hydrogen sulfide and chloride is not compatible with copper pipe, so a lot of guys, again, you got to look at what you're going to use. Schedule 40 PVC, folks, please don't use it. It doesn't like the temperature ranges you're typically going to see. And again, I included a little picture here of that happens to be a Honeywell Brockman adjustable pressure regulator. You can start to drop the water pressure that goes through the heat pump because the heat pump doesn't care what the pressure is, it just wants that flow. So even if the house is running at 60 psi, to quiet the system down, you can adjust that pressure as it goes through the heat pump down as long as you meet that flow. So bear that in mind if you have a noisy system. Now we actually have our communicating product, line of family product out there in which on the open loop systems we actually have the modulating valve, and we're going to control that flow rate based upon the temperature difference going through the heat pump, which the installer has the ability to monitor. You still, as you can see in the drawing, need those shutoff valves. You still want to put in those boiler drains, and if it was me, I'd still put in the PT ports just to verify things. Again, RV flow with the internal variable water flow and I-gate communicating controls. Again, here's an example of that Belimo valve. You can see there's unions on each side should you ever need to service that valve. It's a pretty nice valve. Actually, I like it a lot. Not ideal water quality. For brackish or hydrogen sulfide water, use a close approach braze plate heat exchanger to separate that well water from our heat exchanger. Remember, they're still getting that open loop. They have still avoided the cost of that entire loop field. They're still getting that energy savings, but what you are doing as an installer is you are installing a separation of that fluid from the heat pump. So if that heat exchanger fails, it's not going to destroy the heat pump. Water with high chloride levels, again, you want to make sure that that close approach braze plate, I suggest, is a titanium. Always contact the manufacturer for that braze plate to have them help you in sizing for the flow rate and water temperatures in heating and cooling. This is critical because a lot of braze plate manufacturers, they produce data for you, but it doesn't get into the low temperatures you're typically dealing with for open loop. So you need to reach out and say, this is my flow rate, here's what my entering water temperature is, and I need a good 10 degrees difference. What size does that need to be? And by the way, here's the fluids I'm running through it, and here's the test results. Have them help you. Remember, they want you to buy their product, so they are more than happy to help. Don't guess at it, folks. Copper pipe should be avoided if you are having less than good water quality. Again, these items that are not compatible with copper, so you kind of think about what material you're going to use. Here's an example, a little drawing. You can see that braze plate. So we've separated the well water with that braze plate. But now what we have, folks, is we have a closed loop between that braze plate and the heat pump. I would suggest that you always make that a little bit of antifreeze, and if you're going to bring it down to 15 degrees protection, don't forget to cut that FP1 jumper that we have, that JW3 on our board. But guys, don't make the mistake of using the well water on site on that closed loop side. Because remember, now between the braze plate and the heat pump, that's closed loop. Always bring that water with you and make sure it's good quality water. Because, gosh, what did you do if you use the on-site water? No advantage at all. If you're using our product that has the internal pump and flush ports, well, you just, made your installation life a whole lot easier. Again, you can see that braze plate heat exchanger and the components required on the well water side, the solenoid valves on the outlet, making sure it's fully flooded. But now on the closed loop side, well, we've already got the variable speed pump, the flushing ports built right inside that unit. So your installation becomes just a whole lot faster. Service maintenance and troubleshooting. Always fill out and retain a dated startup form for a baseline. In other words, you go to start up a unit, you should always be doing a commissioning worksheet. And in there is going to be your flow rate and your temperature differences, making sure that the capacity of the machine is where it needs to be. And that should be the reference point, because when you do that with a freshly installed heat exchanger that's clean from the factory, when you come back later to do the same kind of a performance, as you see that temperature transfer being less, several degrees less, well, that's your clue that it's probably starting to foul the heat exchanger. It may be time to service it. It also will help you kind of gauge the frequency that needs to occur. So again, always perform that on startup. It's also for you service contractors, that is a service contract opportunity if you think about it. Here's an example of our commissioning worksheet. You can see in the heating or cooling cycle, you check the box, you fill out all those flow rates and CFM and things of that nature. Again, date it, model number, job name, all of that, and put it in your project file. If you have the ability, most homeowners do nowadays, to make a copy and keep it on site with the heat pump, that's not a bad thing to do either. So what do we do when we need to service that heat exchanger? Well, use only safe, non-toxic cleaning solutions, and always check with the equipment manufacturer to make sure, well, they approve of it. What are some options? Well, I included a few here for you. On the far right, you can see just, vinegar. Vinegar is typically used to start to descale and delime things. CLR, a lot of people use that. Again, that's something that's non-toxic that you can run through there. A lot of contractors actually use ice machine cleaner, because if you think about it, ice is typically consumed. It's a potable fluid application, so liquid ice machine cleaner. Again, always make sure that you're touching base with the manufacturer to make sure it's appropriate for the material you're flushing it through. So ice machine cleaner is typically a pretty good choice. How are you going to do that? Well, you need a little plastic bucket, little pump of some form, and the ability to flush it through that heat exchanger. The good news is that they're fairly readily available. I'm going to show you an example coming up here. So if you have our product with the internal modulating valve, you need to open up that valve. So depress, power the unit off, depress the knob, turn it 90 degrees. That locks that valve open. Don't forget to close it when you're done, by the way. And for the 1-inch valve that's built inside, again, that's Belimo internal modulating valve. You power the unit, push, release the button. You can see a button there near that electrical connection. Then turn that handle 90 degrees. That opens it again, returning it back when you're done. The good news is for those cleanings, the kits are fairly available and they're not badly priced. Tankless water heaters, that's a very popular item these days, and most all of them tell you have as a contractor or a homeowner, you have to go out there and descale or delime them. So there's a lot of kits out there. It's kind of a nice little one. That's the self-priming pump. Looks like a little sump pump. It's on a stand. Comes in a bucket with a screw-down lid, as you can see. Comes with some washing machine hoses, so it's kind of all together right there. So not badly priced, and it's all compact. So you can see here that you're supplying that cleaning solution through in this case, a tankless, but I'm telling you can use this product to go through the heat exchanger or the heat pump. Returning it back, you can see at the bottom the discoloration after about 20 minutes of flushing. So guys, don't race through it. Make sure you give it the due time it needs. And by the way, always wear eye protection. After you perform a cleaning or service, fill out, date, and retain another commissioning work form so you can compare those results so you know how well you did and are you done in fact cleaning. Always walk around and inspect the discharge pipe and that termination location if you can, because I've seen a couple of instances where, golly, things have gotten grown over and or the beavers have come up and kind of built it into their den and you can't get to it. So if you have that ability, always take a look at the discharge piping, make sure everything's in good shape. I usually would place threaded caps over the boiler drains that I used for the service and the flushing. And I remove the handles and I put them in the blower box of the heat pump because, well, I just didn't want homeowners or their 5-year-old boy while giving his Tonka toy a good washing. So that's just what I did to kind of prevent monkeying with it other than the professional serviceman. And we've reached the conclusion of this presentation, so I'm certainly ready to take any questions if any of you have some.
Thanks, Sean, for a great presentation, and now I'm going to have you address some of these questions that have been submitted throughout the program. One viewer asked, I did an inspection on ClimateMaster here and would like to know what the maximum you can get out of a well system, open loop spring water.
Well, that one's a little hard to answer because regardless of the manufacturer, that is really dependent upon the well recovery, in other words, how quickly it can recover the water you've drawn out of it, the horsepower depth of depth of that well pump, as well as that piping size, and then let's talk about the controller. So that's kind of a difficult one to answer. I will say this, on any heat pump, you never want to exceed 5 GPM per ton because then you could start to cause erosion on the heat exchanger. Not sure I fully answered that question. It's a little bit difficult to give a straight up, this is what you need to look for, because there's a lot of variables that can certainly impact that.
What is the typical discharge rate of residential wells for potable water use only?
Discharge rate for typical homes. I'm not sure if that means just what the home itself consumes or if that's what we're going to discharge out of the heat pump. I'm not really clear on that question.
Are there any problems with the plate type heat exchangers blocking or fouling up on the well side?
Well, again, yes, there is. If you have not done due diligence, if you haven't really taken a good look at that water and done some of those tests that I mentioned, yeah, you can plug them up. You saw in the drawing that there was an inline filter. If it was me and a brace plate, I would always put in some kind of a filter, whether that be a spin down kind of a filter. It could even be like an 80 mesh screen filter in a canister. I set one up a few years back to where the homeowner really wasn't on site. This was a rental property and maintenance was, well, non-existent. So what I did was I set up on the bottom of a spin-down filter where it typically had a drain valve, a ball valve. I actually put a sprinkler valve and put a sprinkler timer so that at 2 o'clock in the morning, 3 times a week, it would open up and flush itself out for 10 minutes and then close back up. So you always want to make sure that you're protecting a brace plate from any particulate that could start to plug them up. That was just one of the methods that I implemented.
Do you need an expansion tank on the closed loop between the brazed plate and the heat pump?
Probably not, because you're typically not going to reach those kind of temperatures. If you put one in, make sure it's a very, very good one. With our units with the internal pump, we actually have an expansion tank with a valve on it that you can isolate it. And bear in mind that it is a stainless steel canister and has a different kind of a bladder. One of the dangers about an expansion tank is that when that bladder ruptures, now you've introduced air and you got to come out and deal with it. You're going to have a unit that trips out. So having done a couple of those, I never did put in an expansion tank, but up in the Seattle area, well, I wasn't dealing with a lot of cooling temperature, which is expansion. So I probably wouldn't, but it doesn't mean you absolutely cannot. You just got to make sure you use a very good one. If I was going to put one in, it would probably be the domestic hot water one. It's got a better bladder, a little bit better pressure rating. But heavens, if you buy the unit with the internal pump, it's got an expansion tank already built in.
On brazed plate heat exchangers, when would you use stainless versus titanium?
That's going to be predicated on the chloride levels, where quite honestly, if it was me, if there was any chloride at all, I'd just get a titanium heat exchanger, be done with it, because one of the things about well water, it doesn't always remain the same. It can change from time to time. Usually it's not very drastic, but if it was me and it was my company's exposure, if I found that I had chloride levels, frankly, of almost any measurement, I would probably just make that a titanium heat exchanger, because again, that homeowner has avoided the cost of a ground loop, so there's still money ahead.
One person asked where they can download the ClimateMaster commissioning form.
That's typically available at the website cmdealernet.com, all one word, and I believe it's under forms. You should be able to find that.
How is the closed approach heat exchanger sized?
Well, any heat exchanger is sized based upon flow rate and temperature that's coming in and you want to achieve out of it. So what I said in that presentation, you want to make sure that you tell the manufacturer. You notice I didn't say manufacturer's representative. Sometimes those guys aren't the best source for you. Some of them are very good, some of them, well, they're just sales guys. So I typically go to the manufacturer if at all possible and say, okay, here's what I have for fluid, here's my results. So I want to make sure that they are okay with the kind of fluid and the composition of it, so they are comfortable with their heat exchanger materials. I tell them this is my temperature that I'm bringing into it, so across the country it's anywhere from the, oh golly, down in Florida it'll be, I think, in the mid-60s up to, we dealt with a guy in Montana last week that was 48 interdegree water temperature. And then I'll tell them this is my entering water temperature, here's my flow rate, and here's the temperatures I want to achieve on the other side. In other words, here's my transfer rate. And they will size that for you. Most of them will actually send you a computer-generated printout that shows you flow rates, temperatures across it, pressure drop. It's probably more information than you wanted, but they assisted in giving you the proper sizing.
How often should you change antifreeze in units?
You wouldn't ever have to, because it should never reach temperatures that would ever break down. The reason you have to in automotive is because it gets pretty hot. In closed-loop geothermal, typically you're not dealing in the temperature ranges where the fluids break down. And if you're using the alcohol-based, if it was me, I would be using the ethanol alcohol and probably put in about 20 to 25%. And the alcohols don't break down as long as they're closed up and not open atmosphere. So you wouldn't really ever have to do that.
Have you seen a well pump run by solar for heat pump application?
I've heard they're out there. I have never seen one. It would make sense, but what happens when the sun goes down?
Have you ever seen calcium react with phosphates, as in corrosion inhibitor and propylene glycol, to form a precipitate or outgassing?
I've seen some buildup, but I have not experienced the outgassing component. So I guess the answer to that question is really no.
Okay, well, it doesn't seem to be any more questions, so this concludes today's webinar.